Lesson 10.5 is on experimental probability. So in this lesson, we are going to determine the experimental probability of an event and use experimental probability to make predictions. There's a bunch of vocabulary in this lesson: experiment, trial, outcome, sample space, event, probability, experimental probability, and prediction. So here, an experiment is an activity involving chance. Each repetition or observation of an experiment is a trial, and each possible result is an outcome. The sample space of an experiment is the set of all the possible outcomes. So here, one experiment that you could have is rolling a number cube. In this experiment, our sample space, you can roll a 1, 2, 3, 4, 5, or 6. You could also toss a coin. Heads or tails would be the sample space. And then having a spinner, spinning that spinner, you could have different results. Now this is in black and white, so in your book you'll see that it's in color, and the colors are red, blue, green, and yellow. So in this lesson, we'll look at identifying sample spaces and outcomes. We'll look at estimating the likelihood of an event, and then going into finding experimental probability and what that means in these different situations. So we are going to start by identifying sample spaces and outcomes. Remember, the sample space of an experiment is the set of all possible outcomes. So here, the first example, tossing 2 coins. We're going to identify what that sample space is. So looking at the sample space, what would happen if we toss 2 coins? So the first coin could either be heads or tails. The second coin could also be heads or tails. So if I start it with a heads, my second coin could either be heads again, or if I start with heads, it could also be tails. If the first coin ended up being tails, the second coin could be heads, or I could have tails. So tails, then tails. So there are 4 possible outcomes: heads, then heads, heads, tails, tails, heads, tails, tails. And then here, we need to show state the outcome shown for the experiment. So here, our outcome, our first coin has a heads, so heads. And then the second coin is tails, so heads, tails. Or if you want, you can abbreviate that as HT. The second example here, I'm going to go ahead and add these colors in here so we can see them or know which color's what. So this guy is yellow, green, red, and blue. So it says identify that sample space. So the sample space here is just all the colors that are on the spinner. So we can list them out. So we have yellow, green, red, and blue. Then our outcome, we have to see where the spinner is pointing, and the spinner, the arrow of the spinner is where it lands, so the arrow is right here. So the outcome shown would be green. Down here at the bottom, there's a check it out problem. It says identify the sample space and the outcome shown for the experiment, rolling a number cube. So go ahead, take a moment, pause the video, and resume when you are ready to check your answer. So here we have a cube. So our sample space would be all the numbers that are on the side of the cube. So on the side of the cube, we're going to have 1, 2, 3, 4, 5, and 6. And the outcome that is shown on the cube is 3. So the outcome here is 3. So sample space is all of the possible outcomes, and then the outcome here is just what is shown in our picture, what actually happened in that trial. So now we're going to go ahead and look at the likelihood of something happening. So it says an event is an outcome or a set of outcomes in an experiment. Probability is the measure of how likely an event is to occur. Probabilities are written as fractions or decimals from 0 to 1 or percents from 0 to 100. So here we kind of have a scale of words that correspond with the percent of something happening. So something that is impossible to happen is going to be 0%. Events with a probability of 0% never happen. From 0 to 50%, it would be something that is unlikely to happen. At 50%, it's as likely as not. So there's a 50-50 chance that it will happen or won't happen. Events with a probability of 50% have the same chance of happening as not. So 50% certain, 50% impossible. Then the range from 50 to 100% would be pretty likely. And then 100% is certain. Events with a probability of 100% always happen. Okay, so we have this range from 0 to 100%. So we're going from impossible, unlikely, as likely as not for 50%, likely, and then certain is 100%. So in this next example, we are going to be given statements, and we need to estimate the likelihood of an event. So we're going to use that scale that we just looked at and write impossible, unlikely, as likely as not, likely, or certain to describe each event. So, first one, there are 31 days in August. There's always 31 days in August, so this is going to be certain. Okay, there's a 100% chance of this happening. Carlos correctly guesses a number between 100 and 1,000. So here, 100 through 1,000, and guessing it right the first time, that's very unlikely to happen. There's a small chance that he would guess that correctly. There's a low chance. So in this situation, this would be unlikely. Okay, so this was a 100% chance. This is a low chance. For C, a coin lands heads up. So a coin has two sides, heads and tails. So this is a 50% chance. So that means our statement would be as likely as not. So there's a 50% chance that it would be heads and a 50% chance that it would not be heads. Cecilia rolls a 10 on a standard number cube. On a standard number cube, you have the sides of 1, 2, 3, 4, 5, and 6. So here, 10 is not on the dice. So this is not possible. So for this would be impossible to do or have happen. There's a check it out problem at the bottom. It says write impossible, unlikely, as likely as not, likely, or certain to describe the event. Anthony rolls a number less than 7 on a standard number cube. So take a moment, pause the video, and then resume when you're ready to check your answer. So a number less than 7. All numbers on a standard cube are less than 7. So this is a 100% chance. And when I have a 100% chance, that means that this is going to be certain. So now we're going to get into finding experimental probability. You can estimate the probability of an event by performing an experiment. The experimental probability of an event is the ratio of the number of times an event occurs to the number of trials. So number of times the event occurs to the number of trials. So you write this as a fraction. The more trials performed, the more accurate the estimate is likely to be. So here, experimental probability equals number of times the event occurs over the number of trials. So we're going to use this and find experimental probability in example 3. So it says, an experiment consists of spinning a spinner. Use the results in the table to find the experimental probability of each event. So here we have the outcome and the frequency. So red occurred 7 times, blue 8 times, green 5 times. So in total, we have to find how many times we ran this experiment, the number of trials. So 7 plus 8 plus 5 will give us 20. So there's 20 trials here. So A says spinner lands on blue. So we need to figure out how many times it landed on blue and put that over the number of trials. So here blue was 8 times, so we're going to have 8, and the number of trials is 20. So 8 over 20. And if you can simplify your fraction, please do. So here we can divide top and bottom by 4. So we get 2 over 5. So 2 out of every 5 spins would land on blue. Spinner does not land on green. So when the spinner does not land on green, it must land on red or blue. So here we want not green over the number of trials. So not green again is red or blue. So we're going to add the 7 plus 8, and the number of trials is 20. 7 plus 8 will give us 15. 15 over 20 can be simplified by dividing top and bottom by 5. So we get 3 over 4. 3 out of 4 spins would land on a color different than green, so either red or blue. So now there is a check it out problem for you to do. You're going to use the information from example 3, so this table, to find the experimental probability of each event. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So for A, it says the spinner lands on red. So we're going to have red over the number of trials. Okay, and remember our total here was 20. So red is 7, number of trials 20. And this can't be simplified, so 7 over 20 will be our answer. For B, the spinner does not land on red, so we want not red over our number of trials. So not red means either blue or green, so we're going to have 8 plus 5 over 20. 8 plus 5 is 13 over 20. And 13 over 20 does not simplify, so that would be our final answer. So now we're going to go ahead and look at example 4. It says quality control application. It says a manufacturer inspects 800 light bulbs and finds that 796 of them have no defects. A, what is the experimental probability that a light chosen at random has no defects? So we have 800 light bulbs total, and we know that 796 of them have no defects. So here we want no defects over our total here. So no defects is going to be 796. Total number of light bulbs, 800. So here we can go and find the percent of this. So if you use your calculator, you would type in 796 and divide by 800, and you get a decimal. You get 0.995. Now to go from decimal to fraction, or decimal to percent, I apologize, decimal to percent, you move your decimal over 1, 2 times to the right, or you could take your decimal and multiply it by 100, and that gives you your percent. So your percent is 99.5%. For part B, it says the manufacturer sent a shipment of 2,400 light bulbs to a retail store. Predict the number of light bulbs in the shipment that are likely to have no defects. So we're going to use what we got in part A, our percent, 99.5%, and multiply that by 2,400. So we're finding 99.5% of 2,400. So we're going to take 2,400 and multiply it by the decimal form of this percent. So our decimal form was 0.995. Excuse me. So we're going to go ahead and multiply that, and you get 2,388. So 2,388 light bulbs would not have a defect, or that's what we would predict. Now there is a check it out problem for you to do. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So it says a manufacturer inspects 1,500 electric toothbrush motors and finds that 1,497 of them have no defects. So for part A, it says what is the experimental probability that a motor chosen at random would have no defects. So we're going to do no defects over our total. So no defects would be 1,497. Total number, 1,500. So then from here, we are going to divide 1,497, divide it by 1,500, and we get 0.998. To get our percent, move our decimal 2 places to the right. So 99.8% would be how many we would expect to have no defects. Then for part B, it says there's 35,000 motors in a warehouse. Predict the number of motors that are likely to have no defects. So we're going to find 99.8% of 35,000. So we're going to take 35,000 and multiply it by 0.998. So 35,000 times 0.998 will give us 34,930. And our label would be motors. So 34,930 motors, and our first answer was the 99.8%.